welcome to 13.6, Circles and Proportions. Okay, so before we get started, I just want to remind you that back in Chapter 9, we studied chords, secants, and tangents, and we learned how to compute angles formed by intersections of these lines. And when these lines intersect, it's possible to find the lengths of the segments formed by using proportions. So similar triangles is going to help us out a lot here. But the first theorem describing the relationship between intersecting chords of a circle is 13.12. If two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So let's look at a picture. So here are two chords that intersect in the interior of a circle. Okay, this theorem says the product of the lengths of the segment of one chord is equal to the product of the lengths of the segments of the other chord. So in this example, AE times EC is equal to DE times EB. Our next theorem is if two secants intersect in the exterior of a circle, then the product of the lengths of one secant segment and its external secant segment is equal to the product of the lengths of the other secant and its external secant segment. Whew, that's hard to say 3 times fast. By the way, for the last theorem, 13.12, there is a proof using similar triangles, and that's on page 567. So I know that you were just dying to go read that proof, but I just need to make sure that you know it's there because we will be looking at the proof. Of course, I'm not testing you on proofs anymore, but I still need you to know what they look like and how to follow one. Alright, so here's a picture of two secants that are intersecting on the exterior of a circle, and that means the product of the lengths of one secant segment and its external secant segment is equal to the product of the lengths of the other secant segment and its external secant segment. So in this example, AC times BC equals EC times DC. So they are proportionate. Alright, so there aren't any examples of this, but there is another proof for our last theorem. That's on page 568. If you're interested in looking at some solutions to odd problems, of course it's always a good study habit because when you come in to do the evens, you at least have a handle on it. But I have some practice problems for you, and just submit them through email and I'll see you in class.